Okie dokie. So, in this video, we're going over some BIT 2406. I think it's chapter 6 at this point. So, we're doing chapter 6, problems 20 through 22. They're all related. Let's jump into it. Just reading through number 20 first. Suntrek, based in China, global supplier, denim jeans. They purchase raw cotton from Arkansas, Mississippi, and Texas. It's flown to ports, transported by flatbed trucks to ports in Houston, New Orleans, Savannah, and Charleston. Factories overseas, yada yada. Contracted with U.S. broker for 71,000 bales. Okay, so they give us basically from the farms to the ports. They have the supplies for each of the farms, and then it's going to the ports which demand this many bales each. So the supply, this is just kind of like a loose, like they have this much to supply. They may not send every bit of it, but the ports that are demanding a certain amount, they need all of those amounts satisfied, met. So they say determine the optimal shipments, blah, blah, blah. Minimize shipping cost. So let's check out just the Excel file and just make sense of it. So here, let's shrink this. Okay. So what values have you been given? What did they come up with, and so on. So right here, we're always going to have like a separate kind of like cost array here. So this is the cost from the farms to the ports, from individual, like from Arkansas to Houston, costs $18 a bale, and so on and so forth. So they're always going to include this in the Excel file. These are the solutions, so we don't plug anything in there. The demand comes straight from this chart here. So we have the demands for all the ports, the supply for all the ports. Now, what is shipped is just the sum of all the solutions for each row, right? So what's shipped from Arkansas is just the sum of all the things that are shipped from Arkansas. Same idea. This is all the sum of those. This is the sum of those. And again, the amount that's shipped doesn't have to equal what they could possibly have supplied. Okay, keep that in mind. So like this can just be less than or equal to this, and that'll play into the solver when we open that up. However, the demand for all the ports have to be equal to what is shipped to those ports. Those ports are demanding those specific amounts, so those amounts better get to those ports. So all of these cells, which similarly are just the sums of the columns, right? Which are the sums of the columns, these cells must be equal to these cells. Now the cost, hopefully it's clear, since all of these are the individual costs from going to each farm to each port, you do the sum product of all of these with all of these, because this is the amount of bales from each farm to each port, okay? That's pretty much it. So with the data, we go to the solver. We check this out. So we're minimizing costs. That's right there, C11. Changing variable cells are just the bold cells here. And then we said that C9 through F9, so that's all of these, had to be equal to the demand of each of the ports. But H5 through H7, what is shipped, can just be less than or equal to what they are able to supply. So that's why it's less than or equal to. You hit solve. It gives you this cost. This is your minimum cost with all these values here. Okay? That was number 20. Let's check out number 21. They say, Suntrek in problem 20 ships the cotton from the U.S. ports to overseas ports in Shanghai, Karachi, and Saigon, where its denim fabric factories are located. So now we are going from these ports that we had in problem 20. We're going from Houston, Savannah, New Orleans, Charleston, and those, from those ports, we are shipping to Shanghai, Karachi, and Saigon. And the demand of each of those fabric plants is 34, 22, and 15,000 respectively. And you'll notice, like in the last one, they gave us that the farms could supply this much. But in this case, they're not telling us how much the ports could supply. But that's because we already know how much the ports can supply, because it gave us the number of bales that each of the ports is going to have to then ship to the fabric plants. They told us with the demand. So it's like the previous chart gave us the demand of the ports, but then now it's going from ports to fabric plants. So what was once the demand of the ports now becomes the supply of the ports, the supply that can be supplied to the fabric plants. Okay, so we'll see that in problem 21 where they set it up. So everything's about the same. Let's just go ahead and check it out. So problem 21, do some shuffling. All right, so remember how we said the demand of the ports originally in problem 20 becomes the supply of the same ports in problem 21. So we have our supply from each of the ports and the demand now of the fabric plants, which we get from this right here. Now, notice how in the last one, in problem 20, I was saying like the amount shipped didn't have to equal what they could supply, but that was for the farms. Now that it's gone to the ports, and the ports demanded 26, 19, 14, 12,000, that means that they have to ship every bit of that because they demanded it for a reason, so they could send all of it to the fabric plants. So in this case, all of these cells will now be strictly equal to these cells, and then same with like the fabric plants. The fabric plants are demanding 34, 22, and 15,000, so they must have that much shipped to each of them. Same layout though, so like all these like shipped are just going to be like some of the columns, and some of the columns, and then these are just the sum of the rows, and so on. We see our costs, again, separate equation for separate chart for the costs. We get those costs right here, and then the final cost, like the overall cost, is just the sum product of these and these. Okay, so now data solver, we are minimizing the cost, C12. Changing variable cells are the bold numbers here. And now what I was saying before, notice how we don't have any less than or equal to, we have strictly equal to. So it's these cells here equal to these cells, and then these cells here equal to these cells. Okay, so we solve that, we get that the cost is this for these values. Okay, that was a 21. So 22, here's a fun one. Suntrek in 21 manufactures denim fabric at its factories and then ships it to the facilities in China, India, Japan, and Turkey, and Italy. The bale of cotton will produce approximately 325 yards of denim fabric. Following are the blah, 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 blah. Okay, so what's changed? All of a sudden they mentioned yards of fabric. In the last ones, we were talking about bales, number of bales of what are we talking about? Denim? Yeah, so bales of denim. Now they're talking about yards of denim. And so they give us the conversion. They say a bale of cotton will produce approximately 325 yards of denim fabric. So what we have to do is kind of the same jump we made from 20 to 21. So we'll do that same jump from 21 to 22, but we also have to convert the bales they were talking about to yards of fabric. But if one bale equals 325 yards, then we can just multiply the number of bales that we have coming from each of the fabric plants by 325. So, just real quick, we'll jot those numbers down. So what I'm saying is like each of these number of bales that are now at the fabric plants are being converted to yards of denim fabric. So each bale is 325, so let's multiply each by 325. 34,000 times 325.
The answer is 11,050,000.
22,000 times 325.
It's 7,150,000.
You get it. All right. And then 15,000 times 325.
The answer is 4,875,000.
Beautiful. And notice these are massive values, but they will talk about the demand in thousands of yards. And so basically we'll have each of these values divided by 1,000. So I should have just done this in Excel. I don't know why I'm wasting time. Let me just do it right here. I'm sorry. All right. Let me just do it again. So we're going to do equals this, the demand times 325. I should have done this before. I'm sorry. So drag this across. This is how much it's going to be in yards for Shanghai, Karachi, Saigon. Shanghai, Karachi, Saigon. And then in thousands of yards, they're going to take each of these and just divide them by 1,000. So in 1,000 yards, we have 11,050, 7150, 4875 coming from now each of these fabric plants. Okay, so that's why in the next problem, remember these values: 1150, 7150, 4875. In 22, check it out. From the plants, Shanghai, Karachi, Saigon, they are supplying this many yards of fabric, of denim fabric, in the units, 1,000 yards. So from there, like once you make that conversion, I think it's pretty much the same problem. So just rearrange this, sorry. There we go. All right. So they have their costs, separate chart right here. They have their supply from each of the factories. We're shipping every little bit, every little last yard of denim. These factories, the jean factories, are demanding this many thousands of yards. That comes from right here. And we want to ship, we want to meet their demands. And then cost is just going to be the sum product of all of these. Now I'm curious, why'd they multiply by 1,000? Interesting. So I think because this is the cost per yard, they might have, did they multiply it by 1,000 to make sure it was the cost per 1,000 yard? That might make sense, actually. Maybe. So if this is like the number of 1,000 yards multiplied by the cost per yard, they've multiplied the cost per yard times 1,000. That doesn't even make sense. That kind of that makes sense. So if you like multiplied this by 1,000, it would tell you how much 1,000 yards cost. Yeah. Okay. So sum product of these and these times 1,000. That's where that comes from. I don't think there's anything different once you go in the data solver. So we might be just about done. So minimizing costs, changing variable cells are the bold ones. We have shipped equal to supply, shipped equal to demand. That's it. Simplex LP, easy peasy. All right, that was numbers 20 through 22. Hope that makes sense. If you have any questions, let me know.